this is Benjamin from the Zephyr project. Today we are February the 23rd of 2024. Well, the day before when I'm recording this, and Zephyr 3.6 is just being released like every 4-ish months. A new major release of Zephyr is out, and I thought I would take a few moments to walk you through some of the things that are what I think are the highlights of the release. Looking at the release notes, actually, there's quite a few things that happened. Look at the scroll back here. It's like really lots of stuff. I want to try and demo a bit of what happened, focusing on the things that can actually be demoed. There are things that are like really low-level infrastructure stuff that just doesn't make sense to demo, right? There's dozens of new drivers that are available, like 30 plus, I think, new boards being supported. Like, just check it out, read the release notes, and if you happen to be interested in a particular driver SoC board and you were looking forward to see it supported in Zephyr, check out the release notes. When it comes to more sort of high-level features, that's going to be the purpose of today's video, starting with, and in no particular order, the new GNSS subsystem. In Zephyr 3.5, you may remember the addition of a new modem subsystem to help with interfacing with modems, right? And cellular modems specifically, and crafting and parsing AT commands and having this kind of infrastructure to make it easier both for driver developers and application developers to interface with such modems. And it turns out that this modem infrastructure can apply quite well to other kind of devices which you happen to like talk to using some kind of AT-based protocol like GNSS receivers. And there's this new GNSS subsystem that happens to provide you with exactly what you would expect from it, which is you hook up in your design your GNSS or GPS or whatever other technology you use, GPS receiver to a UART. You describe this physical this information basically in your device tree, and then the new driver kicks in, and potentially, like for in many cases, if you are a generic a device that's just spitting out NMEA frames, then you can basically use a driver that's already in tree, a generic driver, which is basically what I'm going to do. So there is if you don't remember that, there is this nice way in the Zephyr documentation to navigate and to figure out from a particular API what are some of the samples that are available. There is a sample, and I actually ended up tweaking this sample for my demo today. So this is like basically like you see here, I just tweaked the sample, the GNSS sample, looking at a few things. There is this nice macro in the driver that's allowing me to tell for a given GNSS node and like for a binding in my tree, what is the callback that I want to call in my code to get the information I want, which is a location, right? And so this particular node in my device tree, the GNSS node, for me, adding it was as simple as just telling a link device tree, hey, you know what, under the UART1 peripheral, attached to the UART1 peripheral, there is a GNSS modem, and it's enabled, right? And so driver kicks in, and as driver kicks in, whenever new location data is available, this callback is being called. And in my case, rather than just logging the information on, say, the console, I try and do something useful with it, which is connecting, interfacing with OpenStreetMap. What I want to do is basically have this guy right here, an ESP32 based device, get the information from my GNSS receiver attached over UART, and yeah, display the data on the device. I have Wi-Fi capability on this particular device, so I should be able to compute basically the URL of the OpenStreetMap tile, the PNG file corresponding to my actual position and to the zoom level I want to get, and then download the tile, right? And this should work, right? Let's see. I have my device right here. Let me show you the logs. Yeah, so it looks like the first part is happening. It's trying to compute the URL of a tile based on my latitude, longitude, zoom level, 17 in my case, whatever. It's not quite connecting, but you know what? I said it's Wi-Fi, and in this particular application, my Zephyr shell is enabled. It exposes a bunch of commands. I've exposed the Wi-Fi shell so that I can interact with the Wi-Fi module, scan all the access points in proximity, and figure out, hey, you know what, I'm going to connect to my home Wi-Fi, which is what I'm going to do right here. Connection requested, and as soon as the connection, so pay attention to this guy right here. Connection should be happening in the background. Let's see, I can actually make some room. Let's see right here. Oh, well, you got it. Just happened. It crashed. Don't mind my demo. It's something that I put together in literally a couple hours. This was my first time playing with the GNSS subsystem. Pretty much my first time writing also an HTTP client, which I needed to get the PNG tiles from the server. PNG decoding was also involved. So it's not perfect, but this is where I live, and this is being displayed on the screen. That's pretty cool, right? And that's exactly as you would expect it to be in terms of minimal amount of code required. Like you have a callback that you just define and declare with a macro, and it's being called with your location information. That's pretty cool. One thing slightly related to this particular demo is you may have caught it in passing when I was showing this overlay right here. When playing with devices attached to your Zephyr device, it has one or several UARTs. Whatever devices are behind those UARTs, sometimes you want to like see if they are working as expected. And there's a new driver and a new sample application, rather, I should say, that allows you to easily take and configure in your device tree a particular UART that you would like to behave as a pass-through peripheral, which means that basically whatever happens on UART 1 will be passed through to the console. And so that's all you need to do. You can you stick that in your device tree once and for all, and when you want to quickly see, in my case, is my GNSS receiver working as expected, you can basically go back here. I'm going to switch to my to the demo I have here, but that's basically I created a branch for the sake of the demo, but just to have my custom overlay for this particular board. But this is like the demo out of the box, and so I can build rather than building. Let's see this particular demo. I can look at driver UART, and there is a pass-through demo which I can flash to my device. So let's see. Let's build that guy. And this is it. Well, I flashed the device in the background, but this is it. Like I'm connected to the device, and this saves me lots of wiring and using equipment that will allow me to connect directly to the UART. Like I can just do that quite easily, and this is both ways. Like here I cannot really type because I'm just it's sort of a read-only scenario here, but yeah, pretty cool. Moving on, what do we have? Again, this is in no particular order, mostly the new API and drivers introduced for interfacing with keyboard matrices. I think it was in the 3.4 released, the introduction of a new input subsystem, like a generic abstraction of all things input, be it buttons in the form of buttons hooked up to GPIOs, for example, things like touch screens, etc., etc. For 3.6, there is a really new cool driver and infrastructure for keyboard matrices. So if you're not familiar with keyboard matrices, that's basically what powers your keyboard, and trying to basically have a smart way from an electronic and an electrical wiring perspective, a way to have 100 plus keys on your keyboard and yet not require hundreds of GPIOs in your design to read from those keys and those general purpose inputs. So the driver basically allows you to model in the device tree the rows and columns that make up your keyboard matrix. Also allows to describe the way you actually want to interact with the keyboard, like depending on the kind of GPIOs that you're using for either the rows of all the columns. You might be using an interrupt-driven approach. It might be that based on your constraints, reading the inputs from the keyboard is something that you're only able or willing to do using more a polling approach. So all that is basically described in the documentation, but in a nutshell, like that's how you would describe your keyboard matrix. Like I have basically 3x2 GPIOs that represent both my rows and columns. I guess in this particular example, there's probably 9 keys, right? And describing that as well as many other scenarios. So we're going to demo it, right? So we're going to switch to a different device and a different demo. And moving on to a different branch with a different demo. So let's hook up and let's do this in real time. That's more fun. Great. This is again an ESP32 based device. So let's look briefly at first the actual device. So it's effectively a shield. So like it's too much information here, but the actual device is this guy, and the rest is a shield. Like you can actually kind of tell that it's a board hooked up to a larger design. So this guy is a shield. Anyway, and it's a shield that has, and probably because otherwise the manufacturer would have run out of GPIOs, they effectively use a GPIO expander. So this particular device, the driver is not in the tree just yet, will be soon, but it's a device that, it's a GPIO controller, right? And it takes as an input, it's being controlled and driven by 3 GPIOs, which are used to indicate what is the output you want active at a given point in time. 0, 1, 2, 3, 4, 5, 6, 7, all right? That's what you can control with those 3 lines. So this particular GPIO controller is going to be part of the equation for my keyboard matrix, which I have here, right? The rows, so the inputs, right? They are effectively actual GPIOs of my SoCs, but the columns, the one that I'm selecting on my keyboard matrix, it's being done and goes through the GPIO expander. So that's how I've modeled my keyboard matrix. Knowing that I'm using this particular GPIO expander, I'm effectively using a polling mode. So I'm telling and configuring my device tree to be like, hey, I want to continuously poll all the columns, all the rows, and that's what the input subsystem is going to do for me in the background in a dedicated thread. And once I have that, the code for my application shouldn't be much more complicated than enabling the input subsystem, and in my case, I'm actually interested in playing and tinkering with the shell, because why not? And my app is pretty straightforward. The app itself doesn't do much, but similarly to GNSS earlier, it does rely on some input subsystem magic to easily and conveniently declare a callback in my code that I want called whenever a new input is detected. And in the case of the keyboard matrix driver, the type of event is pretty similar to the kind of event you would get when you press somewhere on a touch panel, on a touch screen. It gives you a latitude, an X and Y, a coordinate of where you pressed on the touch screen. Similarly, you want the coordinates of where you pressed on the matrix. And so let's run the demo. It is compiling, flashing. And what else? In the meanwhile, I guess I can show you that my callback is doing, or is first checking if the kind of event corresponds to something that is effectively a key, as in something coming from a keyboard, and then it does the actual translation between the electrical wiring and the physical layout of the keyboard, which like it's based basically on the data sheet, right? And that's what the code does here. And then as we have the physical key, we can start playing with it and displaying it. So let's see. You can see the console right here. You can see the device here, and yeah, what do we want to type? It's going to be an interesting experience. Luckily, I am left-handed, but yeah, hello Zephyr. And one thing, I sort of intentionally hit the keys quite aggressively here. Things like debouncing and anti-ghosting, like all those features, they are like, this is all happening automatically behind the scenes. Obviously, I could pretty easily turn this particular sample into an actual USB HID human interface device, make it an actual keyboard, right? Like that would be fun, except that, as you can see, I don't have fat fingers, I swear. Those are like really small keys, so it would make for a nasty keyboard probably. But yeah, I think that's really fun. And as you can tell, I hope you can tell, like there's hardly any code that I wrote translating the keyboard matrix, like the coordinates into physical keys. Yes, that's the bulk of the code, because the rest is really just describing as usual things in my device tree. So I think that's pretty awesome, actually. Let's see, moving on. So this one, I don't think I've prepared a demo, but that's actually a good way and a good plug to a session that we're going to do. So you might be watching this right the day off on February the 23rd. In just a few days, on Wednesday the 28th, we're going to do a Zephyr Tech Talk with many Zephyr maintainers and the community at large, and the release managers, Brix and Maureen, to walk through some of the changes. This one is actually really interesting. There is a new services, and quite similar to some extent to what you just saw with GNSS, input subsystem, basically help you, rather than having you write a lot of boilerplate code, providing infrastructure so that if you want to have you want to implement a new server in your application, as in like a new socket for some kind of network service, there's a lot of boilerplate code that usually goes with it, plus some actual infrastructure and resources allocated and required to deal with the particular socket. With the new socket and co-op service libraries, there is basically a common way to declare. I like to call them servlets to some extent. Like, you want to expose a new co-op resource, you want to expose a new service, just like, again, call a macro and just get rolling. So that's pretty cool. We might actually see a demo next Tech Talk, so stay tuned for that, or check out the documentation. One thing that I would like to call out actually is the new there is a new network configuration guide. There's actually been many nice improvements in the documentation. So this is another one, and that's kind of great segue here. One thing that we did is that you can now use basically Google search is built into the Zephyr documentation. So nice tip for you. First is you want to search in the documentation. Sure, you can click right here. You kind of see my pointer. You can click right here, but even easier is just hit / on your keyboard, and like hands-free, you can just search for something, and in this case that would be network. Let's try and see if network configuration gets us the result. Network configuration guide, that's exactly what I wanted to show you, so that's really nice. And yeah, this particular guide walks you through all the kconfigs for configuring and tuning as well, fine-tuning your various network services, and should you want to have like DNS enabled, and what amount of resources you want to allocate to the DNS process, etc., etc., like the various buffers, etc. So that's a really, really nice guide. I really encourage you to check it out, and hopefully, luckily, you will likely stumble upon the guide just by using search, because there's a good chance that now if you're looking for information by just searching for it, you will find it way more easily than with what we had before. Something that's also quite interesting, and we will have more context again during the live stream in just a few days, but Zephyr is now compatible with Trusted Firmware M, so this kind of like comprehensive framework for Cortex M line of SoCs and devices. Implementing all the best practices there, as well as kind of incidentally moving and bumping to the new version of Mbed TLS, latest, I think, 3.5.2. LLEXT tooling. So this one, introduced in 3.5. LLEXT as in linkable and loadable extensions. So in the desktop computing world, or in the Linux world, I guess, you have modules that you can load in your kernel. You have shared object libraries to dynamically load code and run code from existing applications that didn't necessarily know about this code in advance. LLEXT introduces something quite similar, frankly. The ability to package several pieces of functionality and functions, basically, putting them in a binary that you will be able to load at runtime. Think scenarios like over-the-air upgrades, right? Upgrades of your applications. So the infrastructure is there. The LLEXT subsystem basically allows you to call APIs to load a given binary. It's going to be an ELF file, basically. So there's some magic that needs to happen under the hood to make sure that it's properly like loaded in the memory of your running application. There might be some addresses that need to be translated and whatnot. But the infrastructure is there. It's been there since 3.5. One thing that's new in 3.6 is a really convenient way. Okay, so what do I want to show you here? And I'm going to bring yet another device in the mix, this time an STM32 board. The sample, I trimmed and removed and pruned some of the things that I didn't really want to use. But in a nutshell, I want to create a dynamic UI, and that's typically what you would do with what that would be one application for LLEXT. You want to push new upgrades of your application, and the UI typically would require code, right? It's not like we are running HTML and JavaScript and whatnot, and that you just have to put to deploy new text resources. It's like actual binary code UI applications typically. In my case, again, I used LVGL, and so the app basically is doing what, and I think it might actually make a lot more sense to look at in action. But basically, I'm creating a display, right? And the actual contents of my display is going to be changed dynamically based on whenever I'm going to click. I have a button. I will have a button on my screen, and clicking on the button will either try to load a dynamic extension if there is one. If not, it's going to display a text template. If there is an extension, it's going to try and call the fill window method or function rather of this extension. And I've created a couple extensions in my code. There is one which is going to be, okay, I have an extension, and this is where the new 3.6 magic kicks in, I can really easily have a compilation unit that defines a function. In my case, it will be, okay, I want to fill the UI with this particular text, and then declaring that that's what my module exposes this particular extension and function. Similarly, another kind of extension could be, again, I want to fill the window, but this time with a progress bar. And same, like I described this particular extension using the macro right here. It could be loading an image. It could be loading like the Zephyr logo, whatever. You get the idea. And yeah, and so then building those extensions is really as simple as adding to your CMake file the fact that you have sources that actually correspond to LLEXT stuff. And then there is this magic target that's going to take a source file, like a C file, and turns it into an LLEXT output. And so what does that mean for me as a someone who actually wants to use the stuff? Well, I can basically build my application. So for the STM32, that's the that's the discovery board. What else do I need? And the application I said is samples, subsys, display, LVGL. Let's look. So right now in my build folder, well, this is what I was running before in terms of demos. Let's see. This is a new shell. Actually, so I will do a lot of video editing probably, but I want to keep some of the steps. I think they could be helpful, hopefully, to some of you. So let's build the demo, and we should be seeing some interesting outputs. What do we have? Zephyr. So we have a new LLEXT extension here. So yeah, opening it as binary is probably not making a lot of sense, but that's effectively an ELF file. So now let's actually switch to the actual device where I want to run the demo. So be back in a sec. All right, we're back. The application is going to run on an STM32 discovery kit. So this is this guy right here. Right now it's showing hello world. It's a button, and if you remember the code from earlier, if I press the code, we're basically looking at this, right? Like no extension, we just create a label saying, hey, it would be good if you had an actual extension loaded. So let's do just that. So what I prepared behind the scenes is basically translated both LLEXT files, the ones that were output as part of the CMake build process. I converted them into hexadecimal so that I can basically use the console to tinker with the LLEXT commands. One command seems to be calling for an extension name and an hexadecimal string for loading. Let's see, you cannot necessarily see that all that well. The load X, right? Like, so that's what I want to do with the long text extension that I've compiled. So that's this guy right here that I want to put in my clipboard, paste, LLEXT doing its magic behind the scenes. Like in real world, you wouldn't be pasting code on the console, right? Like you would be pushing the upgrade over the air. It would be probably encrypted, etc. But you get the idea. The code, though, would be probably the same. Like in your application, you would be like, hey, is there an extension doing such and such? Is there an extension called UART that defines a fill window method? Now, probably. Let's press the button. Yes, there is. So closing and just going just a bit further for the sake of completeness, I can unload extensions, right? I can unload, and there's actually content assist, which is awesome. I can unload UART. If I put back the device on screen, press the button, extension is gone. Removing the device, and you kind of guessed it, we're going to do some slightly more complex QE with the progress bar. Hopefully I pasted that correctly. It's loading. I could probably get some information about it by calling some of the commands right here, UART, the size of the extension, whatever, putting the device on screen. Oh, interestingly, I was still there, but shouldn't be an issue. Hello world. That is the progress bar. I think that's pretty cool. I mean, LLEXT was there already, but the fact that it's now super easy to build extensions, yeah, check it out, basically. So that's one more demo. How many more to go? A few. This one, not going to demo it, but definitely interesting for folks relying on Extensa. User space is now supported by means of MMU. Is it MMU or MPU? Yeah, I think it's MMU with MPU coming soon. So running applications from user space now supported on Extensa. This one should be super quick to demo, but it's actually quite a big deal. Like when you build a Zephyr application, you might have things coming from different places, right? Like you're pulling code from your app, from a variety of modules, from the Zephyr kernel itself, and it might be that some of the code is similar, right? And if you could tell the compiler that it should look at the whole list of things that are eventually going to be end up linked into your app for optimizing the code and the size of the binary, that can only be goodness. And so if this is now supported, we're going to sort of cheat and look in the documentation to see how to actually benefit from it. There's basically two new kconfigs that allow you to, one, enable LTO, and two, enable it in the context of making sure that when you generate your interrupt tables, it's LTO aware and LTO compatible. So we're going to take those two, put them in the clipboard, and yeah, I guess we're going to look at just the app that we were just running before. We're going to go back to the main branch. So this way we have the standard LVGL demo. So we're going to build it without LTO optimization, and we're going to look at how large that is. I guess we're looking at probably a couple 100 kilobytes, because LVGL is not necessarily all that small. 258, and then we're going to enable the kconfig. So I think one is LTO that I remember, and the other I put in my clipboard. There we go. 258, let's remember that. And compilation might take slightly longer, because basically the compiler is going to do more optimization. Yeah, linking phase taking longer. This is real time. Like I'm not gonna edit that one. 258, and we are looking now at 245, which is, I don't know, that's what, like 5%, and about 8 or 10 kilobytes. Not too bad. We didn't do anything else than just ask the compiler to optimize. I don't want to say something wrong, but I would like to think that it's also optimizing potentially the performance, right? Like by making the code smaller, it might have been also, it might have optimized some control structures and some loops and so on. So that's goodness. Moving on. What else do we have? Bluetooth mesh, we're going to talk about it next week during the Zephyr Tech Talk. The native simulator, I don't think I've prepared a demo for this one, but this is basically linking to the documentation of the native simulator, which I highly encourage you to check, because there's a lot that's happened in there in the 3.6 timeframe. More specifically, I mean, yeah, like basically the wall page got revamped. What I really like is that it's now crystal clear what are the peripherals that you may be able to leverage in a fully emulated context, right? Like you're running, you don't want to run Zephyr on your, and I could show the demo, but rather than showing the LLEXT demo running on the actual STM discovery kit, I could show it on running on my sort of like POSIX environment with a simulated GUI. but potentially also hooking up to my like the actual UART of my computer. Real-time clock can be emulated as well. I mean, you get the idea. You can set up a network, all really, really well documented. So that's, I think that's quite nice. What else do we have? Lots of new boards. I think it's 30 plus new boards that made it into Zephyr 3.6. And I might have a couple of the demos. Oh yeah, something else. Hello World for C++. One thing that I get asked quite a lot is whether it's possible to use C++ to write Zephyr applications. It is. It's been pretty much from day one. And I'm actually really happy to see that there is, I mean, we have the Hello World in C, of course, but there's one in C++ as well now. And I think it's a great starting point for anyone looking at running and using Zephyr with C++. Actually, you know what? We're going to run it. Let's see. I need to clear my build folder. And we're going to look at the code as well. This is somewhere in the samples, CPP, Hello World. There we go. It is literally, I think it's the one from the book, pretty much. The C++ book from way back. And it's actually using like the IOStream library, which might be overkill, might not be the best idea based on your resources. But I mean, if you're looking at doing C++, that you have reasons, like you're more comfortable with C++. There is an external library that you want to pull. You don't mind the potential overhead of cartridge collection and so on because you're running on a not so constrained device. But yeah, let's see. Do we have the Hello World running? We do. I mean, it's a super basic, it's a Hello World sample, but it's basically there to give you a sense of what it takes to enable C++. Basically just turning a kconfig on, and that's it, right? And then you have your application right here, regular CMake build file. So that's one more demo. I think that's it. What else? Yeah, we will be back for a new, I mean, you might have started to watch the Zephyr Tech Talks. We are on YouTube. We have plenty of Tech Talks on YouTube. They are actually really fun to record and really, I think the community really enjoys them. We are going to be live on February 28th. So I hope you can tune in if you missed it or if you're watching this video later, like in March or later in 2024 or whenever. I'm going to put the link right below so that you can get and use that as extra context and extra resources for learning more about 3.6. With that, in just a few days, we're going to be kicking off the 3.7 release cycle, which, if all goes well, will also be the next long-term support version of Zephyr, Zephyr LTS 3. So a lot of stabilization will be happening, lots of work being done around new hardware model for the boards, the SoCs. You're going to learn more about that in the next few weeks. Stay tuned, basically, like subscribe to the YouTube channel, join us on Discord so that you can engage, and with that, see you later online. Thank you.